Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Environmental controls are essential in IT environments where equipment reliability and personnel safety must be maintained around the clock. These controls help protect computers and infrastructure from environmental threats such as heat, dust, static electricity, and chemical exposure. Proper environmental management also supports the health and safety of staff by ensuring that workspaces remain free from hazards and aligned with organizational policy. The A+ certification includes climate control, ventilation, and material handling under operational procedures, making this a critical area of knowledge for technicians working in both large and small support environments. Ventilation is a foundational component of environmental control, particularly in computer rooms and data centers where heat builds up quickly. Proper airflow removes warm air from around servers and workstations, helping maintain consistent operating temperatures. Ceiling vents, raised floor ducts, and directional airflow designs are often used to optimize circulation. Without ventilation, localized heat pockets can form, leading to overheating, component stress, and even shutdowns. Effective ventilation is one of the simplest but most important safeguards against thermal damage. Temperature and humidity control go hand in hand with ventilation to create a stable computing environment. The ideal room temperature for computer equipment is between 68 and 72 degrees Fahrenheit or 20 to 22 degrees Celsius. Humidity levels should remain between 40 and 60%. Low humidity increases the risk of electrostatic discharge, while high humidity can lead to condensation and corrosion. These environmental factors are monitored with sensors and tied into automated alarms that alert staff when values fall outside acceptable ranges. HVAC systems, heating, ventilation, and air conditioning, are often custom installed in data centers and server rooms. These systems are dedicated to IT spaces and are designed to run continuously with redundancy in place to ensure failover if one unit fails. HVAC systems remove heat generated by servers, switches, and power equipment, keeping the temperature within safe operating ranges. Maintenance and real-time monitoring are required to keep these systems performing effectively. Even brief HVAC downtime can result in a significant rise in temperature and service interruption. Dust and particulate matter present another serious threat to computing environments. Dust can clog air intakes, coat cooling fins, and reduce airflow, leading to heat buildup and hardware failure. To prevent this, technicians use air filters on HVAC intakes, deploy sealed server racks, and maintain positive air pressure to prevent debris from entering sensitive areas. Regular cleaning schedules, especially in high-use environments, help minimize risk and extend hardware lifespan. Dust control is also tied to visual cleanliness and professionalism in shared workspaces. Cable management is an often overlooked component of environmental safety. Properly routed and labeled cables improve airflow by reducing physical obstructions around fans and vents. They also prevent tripping hazards and minimize the chances of unintentional unplugging during maintenance. In server rooms and desktop environments alike, bundled and labeled cabling supports easier diagnostics and contributes to a safer, cleaner workspace. Cable trays, zip ties, and Velcro wraps are tools commonly used in structured cable systems. Imagine a scenario where a server shuts down unexpectedly. Upon inspection, the technician finds that the system fan is clogged with dust and that the server had been operating in a corner with poor airflow. After cleaning the fan and relocating the server to a better ventilated space, the issue is resolved. In response, a new policy is created to inspect cooling systems monthly. This example illustrates how poor environmental management can lead to downtime and how structured maintenance can prevent recurrence. Surge protectors and uninterruptible power supplies, or UPS devices, help shield equipment from power-related damage. Surge protectors defend against voltage spikes, while UPS units provide temporary power during outages. For critical systems, line interactive or online UPS models are preferred due to their ability to deliver consistent voltage and allow controlled shutdowns. These devices must be tested regularly, and batteries should be replaced according to the manufacturer's guidelines to ensure they perform when needed. Lighting is another important aspect of workplace safety and efficiency. Workspaces should be well lit to prevent eye strain and reduce errors during cable identification or component replacement. Emergency lighting must also be installed and regularly tested to guide occupants safely during power failures or evacuations. Direct glare on computer screens should be avoided to preserve visibility and reduce technician fatigue. These seemingly minor factors contribute to comfort, accuracy, and hazard avoidance in all technical environments. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Material Safety Data Sheets, or MSDS, provide detailed information about hazardous substances used in the IT environment. These sheets include handling instructions, health risks, first aid steps, and emergency procedures for items such as toner, cleaning solvents, and certain battery types. MSDS documents are required by workplace safety regulations and must be stored in easily accessible locations. Technicians should be trained to consult the MSDS before using unfamiliar materials and to follow the specified precautions precisely to avoid injury or contamination. The disposal of electronic waste is heavily regulated due to the presence of toxic components such as lead, mercury, and cadmium in devices like monitors, batteries, and circuit boards. These components can harm the environment if not handled properly. Local laws and international guidelines often mandate that such waste be recycled or disposed of through certified processing centers. Technicians must never discard electronic devices in regular trash bins. Following proper procedures not only protects the environment but also demonstrates organizational responsibility. Paper records and removable storage media must be disposed of securely to prevent data leakage. Sensitive documents should be shredded using cross-cut shredders, which are more effective than strip-cut models in rendering information unreadable. Magnetic tapes, CDs, or USB drives should be destroyed or sanitized according to data destruction standards. Disposal logs may be maintained to track the destruction of sensitive material, especially in regulated environments where proof of destruction is required during audits or legal reviews. Recycling and reusability programs help minimize waste and control costs in IT operations. Instead of discarding all used hardware, technicians can salvage reusable parts or refurbish entire systems for redeployment. Old monitors, power supplies, and memory modules may be functional in less demanding environments or as spares. Certified recyclers often work with organizations to recover valuable metals and ensure proper disposal of hazardous components. Such programs are not only environmentally friendly, but also support financial and operational efficiency. Hazardous materials such as toner cartridges, lithium batteries, and cleaning agents must be clearly labeled with their contents and hazard class. These items should be stored in fireproof and ventilated cabinets away from direct sunlight and heat sources. Safety gloves, goggles, and other personal protective equipment must be worn when handling these substances. All instructions found on MSDS sheets should be followed, and emergency spill kits should be available wherever chemicals are used or stored. Environmental monitoring tools are useful for maintaining real-time awareness of temperature, humidity, airflow, and power conditions. These tools can include digital sensors, networked monitoring software, or integrated data center dashboards. When thresholds are breached, for example, if the temperature exceeds safe limits or airflow is interrupted, alerts are triggered for immediate response. Monitoring tools enable proactive maintenance and help prevent equipment damage by identifying small problems before they escalate. Unsafe conditions must be reported promptly to a supervisor or safety officer. This includes anything from exposed wiring and water leaks to blocked vents and chemical spills. Reporting procedures should include documenting the hazard, the location, and any actions taken. By responding to safety concerns early, organizations prevent injuries, preserve assets, and demonstrate a commitment to maintaining a compliant workplace. Follow-up actions and inspections may be logged as part of internal safety tracking. Compliance with environmental regulations is mandatory in professional IT operations. Organizations must adhere to standards set by agencies such as the Environmental Protection Agency, the Occupational Safety and Health Administration, and local environmental authorities. These regulations may cover everything from electronic waste handling to air quality standards and chemical storage. During audits, inspectors may review maintenance logs, disposal records, and environmental monitoring data to verify adherence. Technicians play a key role in ensuring these requirements are met through daily practices. Environmental policies in IT departments provide a structured framework for safety, maintenance, and compliance. These policies define how to handle equipment, store chemicals, dispose of hardware, and respond to environmental threats. All staff should read, acknowledge, and follow these policies, which are enforced by supervisors and reviewed periodically. During security incidents or safety audits, these policies may be evaluated to determine if proper controls were followed or if improvements are needed. To conclude, environmental controls are an integral part of operational safety and system reliability in IT environments. Technicians must maintain clean, cool, and organized spaces while properly managing hazardous materials and electronic waste. They must use and follow material safety data sheets, report unsafe conditions, and support energy-efficient and regulatory-compliant practices. These topics frequently appear in operational procedure questions on the A+ exam and are essential for daily IT support tasks in both enterprise and field settings. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.